Welcome back to D-Tech Automation. In today's video, we're diving deep into the heart of every process industry, the pressure transmitter. You'll learn exactly how it senses and converts pressure into a 4 to 20 milliamp electrical signal. We'll also explore the three main types: absolute, gauge, and differential pressure transmitters, all explained with animation. And finally, I'll show you a real working demonstration with complete wiring setup and live readings. So, stay tuned till the end. In process industries, pressure transmitters are the heart of measurement systems. They convert process pressure into an electrical signal, usually 4 to 20 milliamps. But do you know how these transmitters actually sense pressure, whether it's absolute, gauge, or differential? Let's understand their working in detail. All pressure transmitters work on the same basic concept. Pressure from the process acts on a strong sensing element, which converts mechanical force into an electrical signal. This small electrical signal is then amplified and converted into a standard output, generally 4 to 20 milliamps, which represents the applied process pressure. When pressure acts on the diaphragm, it causes a small deflection. In piezoresistive or capacitive sensors, this deflection changes either the resistance or the capacitance value. This change is measured using a Wheatstone bridge circuit, which produces a small voltage proportional to the applied pressure. The transmitter's internal electronics then amplify this signal and convert it into a 4 to 20 milliamp current, making it suitable for long-distance transmission. Without signal loss, an absolute pressure transmitter measures pressure relative to a perfect vacuum. It has a sealed reference chamber inside, maintained at zero pressure. So even if the atmospheric pressure changes, it doesn't affect the measurement. That's why absolute transmitters are used where the reference must remain constant, like in barometric or vapor pressure measurements. A gauge pressure transmitter measures pressure relative to the surrounding atmosphere. It has a small vent hole that allows atmospheric pressure to act on one side of the sensor. This way, it measures only the pressure above or below atmospheric pressure. That's why it reads 0 when the process is open to air. A differential pressure transmitter measures the difference between 2 points. It has 2 pressure ports, one for high pressure and one for low pressure. The sensor measures the difference between these 2 pressures, represented as delta P equals P high minus P low. These transmitters are widely used for flow, level, and filter monitoring applications, signal conditioning, and once the sensor detects pressure, the small electrical signal is processed by amplifier circuits. A microprocessor or analog circuit then converts this into a standard 4 to 20 milliamp output, where 4 milliamps represent zero or minimum pressure, and 20 milliamps indicate maximum or 100% pressure. Now let's see a real demonstration of how a pressure transmitter works, along with all the wiring connections required to make it function. For this setup, we'll need 5 components. First, a 24-volt DC power supply to energize the instrument. Second, a multimeter to measure the 4 to 20 milliamp output. Since this is a loop-powered circuit, the multimeter will act as a PLC. Third, a Baumer-make pressure transmitter with a 1/2-inch flush diaphragm process connection. Fourth, an structure external digital display to monitor pressure in bar. And fifth, a 3-core power cable, 1 positive, 1 negative, and 1 shield wire. We're creating a strong loop-powered circuit so that we can observe both pressure in bar and the 4 to 20 milliamp output simultaneously. Let's start wiring. Connect the strong positive terminal of the transmitter to the strong positive terminal of the 24-volt DC power supply. Next, connect the strong negative terminal of the transmitter to the strong voltage measurement terminal of the multimeter. Then, connect the common, or ground, terminal of the multimeter back to the strong negative terminal of the power supply. With this, our loop circuit is complete. Now, switch on the power supply and set the multimeter to measure current in the 20 milliamp range. You'll notice the multimeter shows around 4 milliamps, which means there's no pressure currently applied to the transmitter. At the same time, the external display shows 0 bar. As soon as we apply pressure to the diaphragm, both readings start to change. The multimeter current rises gradually from 4 milliamps up to 20 milliamps, and the display simultaneously shows the corresponding pressure value in bar. This clearly demonstrates how a pressure transmitter converts applied pressure into a proportional 4 to 20 milliamp current signal, providing accurate and reliable pressure measurement for any industrial process. I hope this video helped you clearly understand how pressure transmitters work. In the next part of this pressure series, we'll go inside the transmitter to explore its internal components and signal electronics. If you found this helpful, don't forget to like, share, and subscribe to D-Tech Automation, your channel to learn process automation made simple.